All right, so hello everyone. I am Myranda Shirk. I'm a senior data scientist at Vanderbilt's Data Science Institute, the DSI. And I'm really excited to be leading this workshop today on large language models as a research accelerator, also known as AI-assisted programming, specifically for neuroscience for BrainHack this week. If you want to follow along, I highly recommend it. This workshop is interactive. So go ahead and download that notebook if you're interested in following along. And if you haven't already, we are going to be using ChatGPT. I will be using ChatGPT live. So I highly encourage you to either, if you are affiliated with Vanderbilt and you have a VUNet ID, you can actually go to vanderbilt.ai and access Vanderbilt's enterprise version of ChatGPT. Very useful and free to you. Otherwise, you can create a ChatGPT account with a free trial, or you can access it for free on Microsoft Edge using the Edge browser. Never thought I would be recommending people to download the Edge browser, but take it out of your recycle bin if it's there. You can access Bing GPT there or whatever LLM you'd rather choose. So if you have one that you like the best, go ahead and have that ready. So the notebook is available right here on that GitHub. Hopefully you're able to get to that. I will go ahead and pull it up. So just a little bit of introduction before we get started with the coding part of this workshop. So as I mentioned, I work at the Vanderbilt Data Science Institute, the DSI, and I'm also part of another hackathon called Ocean Hack Week, which is, as you may have guessed, focused on oceans and ocean science. So this is my first time being part of a neuroscience event, so I'm very excited. I'm usually dealing with environmental and ocean data, but if you're interested in oceanography at all, you can actually see a very similar talk. How this talk came to fruition is originally a talk that I gave at Ocean Hack Week, and that should say 2023. So if you're interested in looking at that, it is similar. You can open it like that. Okay. So the purpose of my talk today is to talk to you about how LLMs can help us push the boundaries in our research and actually get code out faster without sacrificing much in quality. And if you've ever done a hackathon before, or if you're a programmer, you know that this involves a lot of debugging, writing code as fast as possible and not as clean as possible, running into lots of errors, spending hours over documentation and trying to fix those errors. And a lot of times in these events, hackers find that they are spending maybe 90% of their time reading documentation and trying to get through error messages. And then the last 10% of your time in events like this is actually spent on the actual science part of your project. This has just been a thing about hackathons. There's still a lot of debugging is how it works, but it's all about to change with AI. And we call this an AI-assisted workflow or AI-assisted programming. So specifically, large language models is what we're talking about when we're talking about AI, and they have an incredible ability, especially recently, to write, read, and debug code. So there's a large shift towards this new workflow. Even at the DSI, we have master's students who are learning how to use AI-assisted programming in classes and focusing more on how to tell the AI what you want your code to do, and then focus on the design aspect of your code rather than focusing on small syntax errors. So planning the purpose of your code and then allow the LLM to do the really annoying part of going through debugging. So if you're interested, we actually do a lot of workshops on this at Vanderbilt. And we do have, I linked this article here, which is probably my favorite instance of this, in which we had a professor come to one of our workshops on LLMs and then left having implemented a birdsong classification model just a couple hours after attending our workshop and learning about this. So it's very exciting. I really love the implications for people who are, for scientists and programmers to really get together and be able to work more completely together. So before we actually start to use them, I think it's very important for us to understand what these models are, how they work, why they were made, and what they're supposed to do. Because a lot of the abuses that we see of these models or people not using them correctly is just because maybe people don't understand how the models actually work, what they're trained to actually do. So here we're talking about generative AI. You may have heard this before. The G in ChatGPT is generative, and this means that the models are trained to generate text. And the way that they do this is that they're predicting the next probable word, or in code, they're predicting, the next probable piece of code. How they do this when we're training a model is you give the model a sentence, you randomly what's called mask one word, or you hide one word, and then you have the model guess what that word is supposed to be. So if I say my favorite blank is pizza, probably my favorite food is pizza, or my favorite meal is pizza, right? If you blank that out, you can get it through context. So that's how these models work. They're predicting the next probable token or word. Token is just you can think of it as a word. And then a lot of these models that have come out, such as ChatGPT, Bing GPT, we actually don't know the exact training data that was used. Sometimes they will publish it, sometimes not. But they have said that it is freely available information on the internet. So Wikipedia, right? Wikipedia, forums, stuff like that. So you can imagine that there's probably a spectrum on the internet of correct and incorrect information. Maybe you have even come across incorrect information on the internet before. And so you want to keep that in mind. These models, the number one job of these models is to generate text, regardless of factual correctness. It's not a fact-checking machine. It's not scientifically accurate, it's not code accurate, it's generating text. And it's very good at this, at imitating humans writing code, humans writing paragraphs, humans writing songs, because it's been exposed to this a lot on the internet. So just keep this in mind, that they're not perfect, they're generating text. Now, just to go over the tools a little bit so that you can be familiar with some of the models. So ChatGPT, I call this one the darling of the AI world because a lot of people know about ChatGPT. A lot of professors are very sad that people know about ChatGPT. Writing emails and essays. You can get a free trial, as I mentioned before, or you can access it here if you're affiliated with the Vanderbilt. We've got a couple different options for this. We've got 3.5 and 4. 4 is the most recent model and it offers better performance, but it has a more restrictive rate limit. So if you need to send a lot of requests, you may want to go with 3.5. And it processes less words or less tokens than 3.5 does. So you can read more about that specification if you're interested. We've also got some more models to cover as well. So just quickly, it does cost a little bit of money. No updated knowledge past September 2021. That's when they trained GPT 3.5, 2021. So anything that has happened since then, like recent events, it does not know about. So don't ask it about that. And then it has a suite of tools and it's developing rapidly, right? So whenever I'm developing talks like this, I am usually putting in information like this week because there's stuff changing all of the time. So don't take this as this is how it's going to be forever. It's changing all the time. I'll be using GPT-4 in this tutorial to generate the Python code. But like I said, there's Bing GPT. I think this is free if you download Microsoft Edge and you can access it. And this can access the web for its answers. So it actually can use a search engine. And then we have some other tools as well that I'm sure you've all heard at least some of these. So GitHub Copilot is available as a plugin for VS Code. I highly recommend it. You can get it for free with a school email. Don't pay for it. Google Bard available through Google. Poe. Perplexity is one that has come out recently. It's actually a search engine large language model. So it's able to combine like chatbot answers with also links to sources, which is very useful. Llama is open source if you're worried about privacy. You can run it locally. And then LM Studio is a new, really nice software for running these models locally. So just a little bit of an overview of what kind of models we're looking at. Like I said, I'll be using ChatGPT, but it doesn't really matter which one you want to use. So this brings us to this AI-assisted workflow. And what you may notice here is I start with what's called prompt engineering. This is getting your prompt ready for the model. So if you remember using Google, or when Google came out, there's a correct way to Google, right? Like maybe my grandma is not as good as Googling it as I am because she doesn't know what information Google wants from her, right? So you want to think about your prompt that you're giving to the model, just like you think about it when you put it into Google. So prompt engineering just really helps you hone in on what kind of prompt you want. There's a bunch of different strategies. There's a paper out that actually the chief data scientist at the DSI co-authored on different strategies for prompt engineering. And so just to go over a few, One really popular one is called the persona, where you tell the model, you are a programmer, you are a neuroscientist. Now, give me information about this. And it kind of gives it that context of being like, oh, I need to be in the programmer space. I need to be in the neuroscientist space. It's more likely to give you the information that you want. Another one that I really like is telling it to ask you questions until you can do a specific task. So if you want to deploy something onto the cloud, for instance, you can tell your model, I want to deploy an app on the cloud. Ask me questions until you understand enough about my app to tell me how to do it. That's a really great strategy to make sure that the model gets all of the information and then can give you exact instructions on how to set up what you want to do. So a bunch of different strategies for prompt engineering. I highly recommend that you spend time on your prompts. So prompt engineering. Then you want to give feedback. So if your answer is not optimal, if it didn't give you what you wanted, tell it that. It's really good at saying, oh, I'm so sorry. They're usually very polite. It'll say, oh, I'm so sorry, I messed up. Let me give you, this other answer. And you can give it even more details on why it's wrong, or, documentation of a specific Python package, example of what you want. So I'm very good at that. Third step, run the code. You can actually send any errors that you get to the model as well. Some models can run code themselves. GPT was able to do this, actually implement a virtual environment for itself and run the code and then debug its own errors. So it can do a little cycle thing, which is really cool. But if you're running it yourself, run the code, send any errors to the model. It's able to help you with those. Rinse and repeat this part 1 through 3. And then you're able to use it. Move on to your next task or start back at step 1. You're able to get more work done faster without, cursing over documentation, package documentation, looking through forums or on Stack Overflow. So a very, very useful tool. But I do want to highlight here that it's still important to understand what your code is doing. Maybe the ways that I see AI-assisted programming going wrong is when people are using AI-assisted programming and then not reading what the model gives to them. You can copy and paste the code, but then try to read through the code. If you're new at Python, if you don't know as much coding, you can ask ChatGPT to explain each line of code to you. Just make sure you understand what your code is doing. That way, when people ask you about it, you can answer questions. And if something goes wrong, maybe how to fix it, or at least how to ask the model how to fix it. Okay. So hopefully you're able to access the notebook as well as a model of your choice. I'm going to do something a little bit dangerous. I'm going to take you through this AI-assisted workflow through a project just live. We're going to all do it together and compare our answers. We're going to see how far we can get in this in our 40-minute time slot here. So keep in mind, you can work on this with me. The answers that you may get may be different from the answers I get. That's okay. Maybe if you get something interesting, write it down and tell me afterward, or we can all share or something. Use prompt engineering to steer the model in the direction you want to go. You can even tell it what libraries you want to use. So, but since it's a demo and demos are dangerous, I did take a screenshot of me going through this entire process at home the other day. So in case anything goes wrong, we can fall back on that, or you can have something to look back on later to see maybe, what else could have happened if we did this live. So here I'm pretending that I am a participant at BrainHack, and I need to come up with a BrainHack project idea. We can actually use ChatGPT to help us do this. So that's what I did. Like I said, I'm a programmer, I'm a data scientist. I know more about oceanography than I do neuroscience. So I didn't know what neuroscience project to come up with, and I was able to use ChatGPT to kind of lean towards something. This is the prompt that I kind of ended up with. Was a little bit of a process with this because for my little project here that we're going to go through, I didn't want any data set that was behind like a login page or something, because then that would take too long for all of us to get the accounts. I wanted a data set that was available through Python, that I could just stream through Python very easily. And then so I landed on this ADHD data set from the package NiLearn or NiLearn. I don't know how you're supposed to say that. So anyway, I was able to guide ChatGPT a little bit, but in your project, you can put in whatever details you want. So anyway, this is the prompt that I did. And it says, certainly, it's always very encouraging. You can use this. Here's how you it just told me how to access the data, explore the data. And then it gave me a couple project goals to consider. but the one that I decided on for this talk today is analyzing visual differences in brain connectivity between ADHD and control subjects. So our project goal today is perform a comparative analysis of brain connectivity for ADHD patients. And now we start the exciting part. So first we want to access the data. In the case above, ChatGPT actually told me how to do that. So it went ahead and gave it to me. But if we want to start this from scratch, let's say I didn't know this part, I could put in something like, how do I access the ADHD dataset from NILearn in Python? And now, oops, wrong one. All right, I've got ChatGPT open. Got this thing. Okay, usually I can hide that. I don't know. All right. Okay. So now I'm just going to ask, how do I access the ADHD dataset from NILearn in Python? All right, it tells me to pip install it and tells me to how to get it. Awesome. So I do already have this in the notebook, so I'm not really going to wait for it. But if you didn't have this already, so we can copy and paste that there. And I run it. Oh, no module named NILearn. So we've just got to pip install that. And it actually told us to do that earlier. So while this is thinking, the next part that I'm going to look at is asking it to help us pre-process this data. So if ChatGPT can help us get our data ready for our project, I don't know what that involves. Like I said, I'm not a neuroscientist. I've also linked the documentation to this data set as well, because that is still good to look over to make sure you know what each column in the data set is. Dang, still thinking. Like I said, this is why I brought screenshots just in case this decided to explode. Oh, here we go. Great, 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 great. Okay, and now it's going to go and get our data sets. So we got the data sets. I'll let that run for a little bit. It's got to fetch some stuff from the internet. Okay, so now we need to pre-process our data for our goal. So we're going to give this next prompt to ChatGPT, write Python code to pre-process our data so that we can analyze brain connectivity patterns. All right. So I'm just going to grab that. This is still going. And paste that right in there. So I'm giving it my goal, saying what I want to do, and then asking it to write the code to pre-process that data so that we can get it ready. I find that the data part of this is very, very useful. ChatGPT is great for helping you find data sets. It's very great for helping you process those data sets or get them ready for you. So here it goes. It's going ahead and actually fetching that data again, and then it's going to get them ready for us by creating the connectivity measure, fitting it, and then creating our connectivity matrices. So if I say anything that is neuroscience incorrect, please forgive me. Okay, and so now it says, remember, this is a basic example. In real world scenarios, you may need to do some other things, but we're not going to worry about that for now. We just want to see if we can access our data and perform, sort of a mini project altogether. So I'm going to copy that code that it gives me. And now, okay, it downloaded that data. Now I'm going to paste in this pre-processed data. And what I'm going to do up here, because I already loaded my data set, I'm actually going to get rid of this. I don't want it to fetch the data set again. That will take too long. Importing the libraries is fine. Okay, now if we let that run. Is what? Does it generate the same code every time? Is that what you said? It does not. No. So that is one interesting thing about it is, like I said, it's kind of predicting one piece at a time, right? And so there's a little bit of randomness that is added in there. it will be different codes. So one person running it may get different code from another person. It's not necessarily that it's going to be wrong one time and right the next time, but it does do different ways of doing it. So what we can actually do is kind of look at what it gave me before. Yeah, it could. I haven't tried it extensively with this project idea. But it will, yeah, it will generate different things. And you can actually, there's something called temperature on these models, which is kind of, you can think of it as creativity or randomness. And adjusting that temperature value for models can help determine if you're going to get the same thing every time or something different. So a high temperature closer to 1, I believe, is more creative, so more random. So you're getting more variable results. But then if you bring that temperature value all the way down, it is more likely to generate the same thing every time. So if you want something more consistent, then you can ask for that. And so here is just an example of how it helped me pre-process my data before. It fetched the data and then did, here we go. So it actually did something like this instead. So it's pretty much the same, but it's a little bit different. Okay, so eventually this will finish and then we'll have our connectivity matrices. But next I want to get to the actual interesting part of that, in which I want to do some visualizations. So I said, write Python code to visualize the connectivity matrix. And now it's going to say, okay, great. So to visualize this connectivity matrix, we can use these libraries. And here's an example of how you can do it. Here's one of the ways that you can do connectivity matrices. So I didn't take a picture of all of the code because I copied and pasted, but it gives a little explanation of what it's going to help us do here. It's very nice. It really likes to give you lots of information. And then we get down here where I have code to run a connectivity matrix. So plotting, especially, I love using ChatGPT for plotting because I hate trying to figure out plotting. It's really great for giving you a nice image and then you're not having to run over to matplotlib documentation. So it made this really nice correlation matrix for me. This is for the first subject in our data set. Obviously, there are other things that you could do with this if there are other data processing steps or data visualization steps that you want to take. And then it even helped me make this really nice brain picture, which I am proud of because I'm not a neuroscientist. This is my first brain image that I have ever made on Python, so very proud of that. A connectome. So, and then actually in my prompt, it said you can do this for one subject, or you can generate an average for many subjects or for each group. And so I actually said, that's a great idea. Why don't we do that? So I said, okay, write Python code to create that average connectivity matrix and visualization for two groups, the ADHD group and the control group. It kind of goes over how it does that. And then when I run that code, so it gives me this, helps me separate my data into the correct labels. This is also where it's important to read your data documentation in case you run into errors. ChatGPT may not know what the columns of your data are. So when I was doing this at home, I did have to go and make sure I was getting the correct column, but it was able to create an average connectivity matrix for ADHD, for control, and then those very nice, my favorite brain pictures, the connectomes. Okay, and so now we get to another interesting part. Now I want to use machine learning or statistical analyses to compare the connectivity between the ADHD and the control groups, write Python code to do this. And so it actually gives me two different approaches. It says, okay, there's a couple different ways you can do this. You can use a statistical analysis like a t-test, and then it shows me how to do this t-test. And then it says, or you can use a machine learning classifier, specifically a logistic regression classifier, and then tells me how to do that. So if you are very confident in some areas, but not as much in other areas, you are able to kind of tailor your experience here. So you can say, assume that I'm a programmer and I don't know as much about this, or assume that I am a scientist and I don't know as much about X or whatever. And able to help tailor that. So here, even if you've never done any sort of machine learning, you're able to already go ahead and train a model and then run it through testing, get your prediction, get your accuracy and your metrics like that. And then if you don't know how to interpret some of these results, you can say, what does this result mean? What does this metric mean? And it's very good at doing that for us. Likes to give us lots and lots of information, but I was able to put in my data, separate it out, and then fit a model. Obviously, the model was not very good because I gave it 5 data points. And so it's does not have very good statistics, but the point of this is that we were able to get through almost a whole mini project all together with some debugging. So like I said, doesn't always go well live, but if I go back up to where I left off on here, I've included a little section for you if you'd like to go through this on your own for your own project to kind of take you through this same experimentation phase with your own project. So hopefully this will help you during BrainHack. I encourage you to play around with these models. If any of you were following along and got interesting results, please let me know. It is pretty fun. Like I said, when I am working with ocean scientists and doing this, there's a plot that they have called temperature versus salinity. And when I asked ChatGPT for this plot, it actually gave it to me with the axes reversed. And so the plot was flipped upside down and the ocean scientists were like, nope, that's wrong. That plot is flipped. So we were able to work on it and, flip the plot and kind of help with that domain knowledge. So there's a lot of interesting things that you can do. They're not perfect, as you saw today. But it does help to have someone to at least talk to about debugging and be able to get those answers. So I'm going to try to wrap up here, but please let me know if you have questions or comments or if you had something interesting happen while you were going through this as well. So that's where I will wrap up.